to 22.9%. That's a pretty big jump. And even when we look at the adjusted R squared, it's still 22% of the variability in overall unit quality that's accounted for by the model, which now includes 4 independent variables. Now, this is the crucial crux piece of, or the crux of the analysis. It's the R squared change. The change from R 22.9 from 16.3 to 22.9 is equal to 6.5. That's what this R squared change is. So we've had an increase of R squared equal to 6.5. It doesn't base it on the adjusted R squared, it bases it on the R squared value. So 6.5% increase in predictive capacity going from 16.3 to 22.9. And that R squared change, that 6.5% increase, is associated with a F value of 32.36 with 1 degrees of freedom and 382 in the denominator. And the F change associated with the R squared change of 6.5 is statistically significant. So this is showing that adding hotness to the model increases the model's predictive capacity at predicting overall unit quality in a statistically significant way, and it's increasing the percentage of variance accounted for by 6.5%. And that's pretty big. It's reasonably big. And this Model 2 section of the ANOVA table is new information that is testing the hypothesis that this R squared value of 22.9% is statistically significant, because there's no F value here in this model summary table that tests the significance of this 22.9. This F change value of 32.36 is associated with the R squared change. It's not associated with the overall R squared of the total model. This F value is. This F value of 22.9 corresponds to this R squared value of 22.9% of variance accounted for, and it's statistically significant, p less than 0.001. So there's 3 pieces of information. You get an R squared with the first block of predictors that you're not especially interested in, and you get an F value that's duplicated in 2 tables, 24.895 and 24.895. Then you get an R squared change value associated with Model 2, and it's got an F change of 32.36, and it's statistically significant. And then you get an F value 28.29 associated with the whole model, 22.9% of the variance accounted for. So those are the 3 key pieces of information. Students, take time to digest this information. You might have to listen to me mention it. You might have to back up and listen to me talk about this again a few times to really get what is going on in these 2 tables. It's understandably potentially confusing, but all the information's there, and I can't think of a better way to present the information. It's just a complicated thing. Now, in the last table that's particularly interesting, you get the beta weights and the statistical significance associated with those beta weights, which is important and interesting. Now, in the first model, we can see that easiness, helpfulness, and clarity were added to the model. We should know that we should know that without the output because we added them, and we can see that nearly all 3 are statistically significant. Helpfulness and clarity were associated with statistically significant beta weights, and I'm looking at the standardized ones, but you can look at the unstandardized if you wanted to. But easiness was not a unique predictor of overall unit quality. Now, all this information is similar to what you find in a regular multiple regression. The key difference is that you get an extra model, and you would get as many as you added into the blocks. If you had 3 blocks, you'd get 3 models, but we only have 2 blocks. And we can see that hotness was associated with a standardized beta weight of 0.274 and a t-value of 5.688, and it's statistically significant. And we would expect that because hotness was associated with a F change that was statistically significant.